Everyone, this is an extremely quick video. Just wanted to show you guys, if you were given an equation with respect to x and y, how you can necessarily convert that into parametric form of the equation, or just to find a parametric form of an equation. In this case, we're going to let y be 1 minus x squared, which is easy to go ahead and spot out. You know, our x squared, or our x term being the squared term. We can identify this is a parabola or a quadratic thing that opens either up and down. In this case, since our leading coefficient or a value is -1, we can imply that this is going to open downward. Okay, but we're going to let y equal 1 minus x squared. And that being said, let's go ahead and start with a few outlines here. And in one case, what we're going to do is we're going to let this be true. And this is typically the normal case, but you would choose one of these variables, x or y, and we could necessarily define that as being equal to our parameter, and we call that t. Okay, so in this first case, we're going to let t just be equal to x. And you know what, that's really convenient if we can get away with it, because y is already solved for with respect to x. So just inserting t in here, already you can necessarily see that in this case, y would be defined as 1 minus, in this case, x squared, and x is equal to t, or 1 minus t squared. So we'd end up turning out a couple of equations for x and y as y being 1 minus t squared, and x is simply being t. Now, this isn't always the case. We have a more complex parameter sometimes. So you might see something, for example, like this. We could let t be necessarily like 1 minus x, okay? And we want to, achieve the same goal here, okay? The fact of the matter is this, though. If we're going to get t put up in these equations here for x and y, what we're going to necessarily need to do is solve for either x or y in this equation. And since we have a relation between t and x here, we're going to go ahead and solve for x in this equation. So if we want to go ahead and do this, well, one smooth move we could do here is necessarily change everything to its opposite, or multiply through by -1. And then from both sides, we'll go ahead and add 1 to both sides to eliminate this -1 from the right. So here's what we got. I'm going to go ahead and put our x on the left here. We say x is equal to -t plus 1. Okay. Now that we've got this solved for, or x solved for with respect to t, we're halfway done to the answer. We say, okay, that's our x component of our parametric equation. Let's go ahead and solve for y. And in order to do so, what we're going to do is we're going to take this solve for x with respect to t, and we're going to substitute this back into the original equation right here. Sorry, that looks like I'm pointing at the 2, doesn't it? Anyways, we say, okay, so since y was defined as being 1 minus x squared in the original equation with respect to x and y, we're going to go ahead and remove all instances of an x, and we're going to substitute what we know x equals with respect to t. So -t plus 1. Now expanding this, we can see that we got 1 minus now. Now we say, okay, quantified here, we'll go ahead and expand this. We say -t times -t is t squared. -t times +1 is -t, and that's going to occur twice, so -2t, and then 1 times 1, of course, is 1. And then going ahead and, sending through this -1 here, or this coefficient out in front of this quantity, we have y is equal to 1 minus t squared plus 2t minus 1. And combining like terms, we see that this +1 and this -1 necessarily, they cancel out. So anyways, we say y is equal to -t squared plus 2t, and that is our y component of our parametric equation.